Hello everyone, I am Shoham. I am here to present our paper which is about our team LIPI's approach for the FinNLP 2022 ERAI shared task. Dr. Noskar and I contributed towards this research. We are affiliated to Jadavpur University and Fidelity Investments. Overview. Our aim is to estimate maximal possible profit MPP and maximal loss ML of financial posts. We want to quantify social media posts in terms of expected profitability to mine quality posts. For task 1, that is a pairwise comparison, given two posts, the task is to develop a system for evaluating which of them will lead to greater MPP and lower ML. For task 2, unsupervised ranking, given a set of posts, the task is to develop a system for ranking these posts in terms of higher MPP and lower ML values. Results of task 1 were evaluated using accuracy. For task 2, average MPP and ML values of top 10% posts were considered for evaluation. Datasets. The organizers provided us with datasets D1, D2 and D3 presented here. From these we created D4 and D5. D1 comprised 200 label post pairs which were used for a training and validation. D3 having 87 unlabeled post pairs comprise the test set. The ML label is set to 1 for an instance, that is for a pair of posts when the ML value of the first post is less than that of the second. Otherwise, ML value is set to 0. On the contrary, the MPP is set to, the MPP level is set to 0 for an instance, that is a pair of posts when the MPP value of the first post is less than the second one. Otherwise, MPP is set to 1. The posts in the dataset were collected from Chinese social media platforms like PTT4 and Mobile01. They were translated to English using Google Translate. Task 2 had 210 unlabeled posts which were to be ranked. We refer to this as D2. We created D4 by considering each post in D1 separately. This means you see over here post 1, post 2, then post 1 English, post 2 English, MPP1, MPP2, ML1, ML2, MPP level, ML level. This was divided into two parts for two instances. Firstly is post for post 1, that is we have post 1 translated form of post 1 in English, MPP1, ML1, and the same was done for the second post, that is post 2, English translated format, MPP2 and ML2. We expanded a D4 and we created a D5 by expanding a D4. So we expanded D4 by comparing each post to every other post after removing the null instances. And we refer to this as a D5. So this is how we prepared the data from the dataset which we are already having, that is which was provided to us. A methodology. We present our methodology in this diagram. For Chinese posts in D4 and D5, we extracted their sentence word embeddings using AceBird Chinese QMC Finance. We concatenated the embeddings for a given pair of posts. We trained linear regression models and multi-layer perceptron models to predict the raw MPP and ML values. we obtained the MPP and ML values for a given pair of posts by comparing the raw values of the corresponding constituent posts. Subsequently, we trained a Finbert regression model which takes English posts as input. I mean, English posts of D4, that is this one, as input, and predicts the raw ML values. Finally, for task 1, we ensembled the models based on majority voting. For task 2, in addition to this MPP, which we evaluated, I mean, which we used for ranking. So we use the raw MPP values for ranking, and for ML, for all the English posts in D5, we extracted their Finbert embeddings, passed them through a multi-layer perceptron layer. uh, the target was to predict the difference in ML values, and we used that. So for a given pair of posts, we compared the ML values, and that's how we generated the unsupervised ranking for them. Results and discussions. We present the results for the training, validation, and test sets for both the tasks over here. We used labeled instances from task 1 to measure the performance of models trained for task 2. It is interesting to observe that our ensemble system performance, serial number 1.6, that is this one, is next to that of Team Jetsons in the pairwise comparison task using MPP. Moreover, in the same task using ML, our subsystem is before, here it is referred to as 2.4. This one, this performs as good as the best performing team, that is DCU ML, accuracy 59.77. However, we could not submit this subsystem separately because it did not perform well on our validation set. In the unsupervised ranking using MPP, only team prompt sorts performed better than that of ours. Uh, However, in the unsupervised ranking using ML, the performance of the system developed by Team Yet and the baseline solution was better than those which we had developed. In this case, we did not submit the result corresponding to SV3, that is this one, 2.3. Uh, this is because we, since this was trained on D5, that is a pair of fours, we couldn't evaluate it for task 2 because task 2 consists of only one post. Conclusions and future works. So our models performed consistently well across both the tasks. We obtained better performance with Chinese text than the translated version in English. We conclude that ensembling helped in improving the overall model performance. For collecting more financial posts and labeling them, then we can incorporating prices of the stocks whose MPP and ML values are being discussed into the model directly as input are some of the directions for future research. Thank you. If you have any questions, please let me know. You can also reach out to me by email.